This quiz focuses on how increasing the alpha parameter in ridge regression affects the model. Ridge regression is a type of linear regression that adds a penalty to large coefficients to prevent overfitting. The alpha parameter controls the strength of this penalty. A higher alpha means a stronger penalty. I'm presenting you with a multiple choice question about the consequences of adjusting alpha in a ridge regression model. This lets you test your understanding of the effects of this important parameter. Let's imagine you're using the popular Python library scikit-learn to build a ridge regression model. Scikit-learn's ridge function is what I'll be referring to here. Your model is being trained on data with high multicollinearity, meaning that your predictor variables are highly correlated. You have initially set the regularization strength to alpha equals 0.1. The problem asks how this changes when you increase alpha to 10.0. Increasing alpha directly reduces the size of the model's coefficients. Think of it like this: a higher penalty discourages large coefficient values, making them shrink towards zero. Because the model is being forced to use smaller coefficients, it might not fit the training data as closely. This is expected and usually a good sign because we're trying to prevent overfitting. By simplifying the model through coefficient shrinkage, we introduce more bias. Bias is the error introduced by simplifying your model. A simpler model may not accurately capture the underlying relationships in the data. When you have features with high correlation, the model can become unstable. A higher alpha helps to stabilize the model by making it less sensitive to these highly correlated features. These are the potential answers to assess your understanding of how changing alpha impacts your ridge regression model. Your goal is to select all correct answers. I'm investigating how increasing the alpha parameter in ridge regression affects the model. Specifically, I'm looking at how it changes the model's coefficients, training error, bias, and sensitivity to features. Think of alpha as a tuning knob. It controls how much we penalize large coefficients. This is the core question. I'm evaluating the impact of a significant increase in alpha, from 0.1 to 10.0, on 4 different aspects of the ridge regression model. Let's see if you can ace this. We'll consider how it changes coefficients, training error, bias, and feature sensitivity. I predict that a larger alpha will lead to smaller coefficient values. Think of it like this: a higher alpha imposes a stronger penalty on large coefficients, forcing the model to shrink them towards zero. So I expect the overall magnitudes of the coefficients to reduce. I think the training error might increase because a larger alpha simplifies the model. It's like trying to fit a straight line to a curvy dataset. A simpler model will inevitably miss some nuances in the training data, and thus, its performance on the training data itself might suffer. I expect the model's bias to increase with a larger alpha because the model becomes simpler and less flexible. It's like using a hammer to fix a watch. The simplistic approach might miss important details and lead to systematic errors. Increased bias means the model's predictions will be consistently off the mark in a particular direction. With a larger alpha, I anticipate that the model will be less sensitive to individual features, especially those with high multicollinearity. The effect is that the model coefficients become smaller, reducing the influence of any single feature. The model's predictions are less likely to swing wildly due to the variations in any specific feature. I'm going to explain how increasing the regularization strength, alpha, in ridge regression changes the model. We're increasing alpha from 0.1 to 10.0, a significant jump. Think of alpha as a dial controlling how much we shrink the model's coefficients. A higher alpha means stronger shrinkage. Let's see what happens. With a larger alpha, the penalty for having large coefficients increases. I predict that this stronger penalty forces the model to make those coefficients smaller. That's why statement A is true. When I increase alpha, I'm simplifying the model by shrinking coefficients towards zero. A simpler model makes stronger assumptions about the data, which increases the risk of missing important patterns, thereby increasing the bias. That's why I say statement C is true. Because a larger alpha simplifies the model will likely fit the training data less well. A simpler model may not be complex enough to capture all the nuances of the training data. This leads to a higher training error. Hence, statement B is true. The effect of shrinking coefficients on feature sensitivity is significant. Each feature's influence is decreased, making the model more robust to noisy or irrelevant features. This reduces its sensitivity to any single feature. Hence, statement D is also true. This is a multiple-choice question testing your understanding of how changing the regularization parameter, alpha, in ridge regression affects the model. We'll look at how it impacts the model's coefficients, error, bias, and sensitivity to features. Let's dive in. I observe that when you increase alpha, the penalty for large coefficients gets bigger. This forces the model to shrink those coefficients towards zero, making them smaller in magnitude. Increasing alpha simplifies the model by shrinking coefficients. This simplification means the model is less flexible, and I find that leads to a higher bias. The model makes stronger assumptions about the data, potentially missing important details. Because increasing alpha simplifies the model, it becomes less able to perfectly fit the training data. This results in a larger training error, even though the model generalizes better to new data. The effect of increasing alpha is that the coefficients are shrunk. This reduces the influence of individual features on the model's predictions, making it less sensitive, particularly to features that are highly correlated, multicollinearity. This line sets the stage. We are dealing with ridge regression, a technique used to deal with high multicollinearity, when your input features are highly correlated. Alpha is a key parameter that controls how much the model penalizes large coefficients. We will explore what happens when we increase this parameter. This title tells us that we'll be focusing on how changing a key parameter, alpha, affects a specific type of machine learning model called ridge regression. Ridge regression is a method used to predict a continuous outcome, and it's particularly useful when dealing with data where the input variables are highly correlated. The parameter, alpha, controls how much we penalize large values of the model's coefficients. Think of it as a dial that balances how well the model fits the data versus how simple the model is. I'm given a scenario where I'm using ridge regression in Sklearn, a popular Python library for machine learning. My data has high multicollinearity, meaning that some of the input variables are very strongly related to each other. I've already built a model, setting alpha to 0.1. Now, the question asks me what happens when I increase alpha to 10.0, a significant increase. This tests my understanding of how alpha works in ridge regression. Increasing alpha increases the penalty imposed on large coefficients. It's like adding a tax on large numbers. This pushes the model to prefer smaller coefficients. Think of it this way: a larger alpha makes the model less inclined to use highly influential inputs. A larger alpha leads to smaller coefficients, making my model simpler. A simpler model might not fit the training data as perfectly. This means the training error might go up because the model is less flexible and won't capture all the details of the training data. Bias refers to how much the model's predictions differ from the true values, on average. By shrinking coefficients, I'm simplifying my model. A simpler model is usually more biased, as it doesn't capture the complexity of the real world. Increasing alpha pushes me towards a simpler, more biased model. With a larger alpha, the coefficients of all features are shrunk. This makes the model less dependent on any single feature, reducing sensitivity to changes in a specific feature and especially useful when features are strongly correlated. It reduces the impact of noisy or irrelevant features. I'll explain what happens when we increase the alpha parameter in ridge regression. Alpha controls how much we penalize large coefficients. A higher alpha means stronger penalization. Think of it like this: we're trying to find the best fitting line, but a high alpha encourages a simpler line, even if it's not perfectly accurate. We'll explore this effect on model performance. We're using ridge regression, a type of linear regression that uses a regularization technique called L2 regularization to prevent overfitting. We're given that we've already trained the model using alpha equals 0.1 and now want to see what happens when we increase alpha to 10.0. I'll show you how this impacts the model's performance across various metrics. Here, I'll summarize the impact of a significant increase in alpha from 0.1 to 10.0. This change will greatly affect the model coefficients, training error, bias, and sensitivity to features. I'll break down each effect in the following rows.